Okay, it's good to see everyone again. So just in case anyone was confused by the supply and demand algebra that we reviewed previously, I was going to make a quick video reviewing some of the key techniques for applying the tools of algebra to solve supply and demand equilibrium. So let's say we have a demand curve. So we're going to start by drawing. Always label your axes, quantity, price. Let's say we have a demand curve that looks like this. And let's say that the demand curve, the equation for the demand curve, is given by price is equal to, let's say, 10 minus 2qd. Okay, and let's say we have a supply curve that looks like this. Let's say that for the supply curve is given by the equation of price is equal to, let's say, 3q, quantity supplied. So now the question is, how do we find the equilibrium, the point of equilibrium at the intersection of the supply and demand curve? So from your principles of microeconomics and macroeconomics courses, you should know that. So the equilibrium is going to be determined at the intersection point, generally. So the question is, how do you find that intersection? Well, anytime you're trying to find the point of intersection of two curves, let me see here. So anytime you're trying to find the point of intersection of two different curves, you can always, it doesn't matter what the curves are. The curves could look like this, or the curves could look like this. If you're trying to find the intersection points of two curves, you just have to take the equation for each of the curves, for curve 1 and curve 2, and set the equations equal to each other, and find the point on the axes at which they're equal to. So let me demonstrate how this is done. Let's move over here. Okay, so coming back to our original example, you have two equations. We have price is equal to 10 minus 2q demanded, and price is equal to, what did we say? Price is equal to 3q for supply. So we're going to set those two equal to each other. So we're going to set this part equal to this part. All right, so then we get 10 minus 2q demanded is equal to 3qs. So because we're trying to find the point at equilibrium, and at equilibrium the quantity demanded is going to be equal to the quantity supplied. We can set quantity demanded equal to quantity supplied. So then in that situation, we can erase the demand and erase the supply, and we just have 10 minus 2q is equal to 3q. Now we just have to solve for the common q. So solving for the common q is relatively easy. Some people just need a little bit of practice. So let's put the q's on one side of the equation by adding 2q to each side. We get, so 10 can be equal to 5q. And now we're going to try and isolate the q on one side by dividing both sides by 5, which yields q is equal to 2. Therefore, the q equilibrium, which I'll call 2 star, equilibrium happens when quantity is equal to 2. But what about the equilibrium price? We're trying to find both, right? We're trying to find price, quantity. We're trying to find the equilibrium quantity, which we just found at 2, but we still need to find the equilibrium price. So how do we find the equilibrium price? Well, we can just plug in the equilibrium quantity into either the supply curve or the demand curve, because they're both going to yield the same price. Because you can just see from the equation. So we're going to plug in, I'm just going to choose to plug in the equilibrium quantity of 2 into the demand curve. Either works fine. In fact, I'll do both. So the demand curve was given by P is equal to 10 minus 2Q. Now we plug in 2 into the Q, so you get P is equal to 10 minus 2 times 2, which gives you 10 is equal, which gives you that 10 is equal to 10 minus 4, which is going to be equal to 6. Therefore, equilibrium price is going to be equal to 6. Done. Now we can zoom in over here and see that this P is equal to 6. So this point of 2, 6 is the equilibrium. Okay, I'll post another video on the algebra of budget constraints soon. I hope this was useful.